spider, kind of a crawling robot, and you want to visualize it. Obviously, it's going to be difficult to put it all in terms. So what we do is, as I said, you define something which is called an URDF, which is a Universal Robotic Descriptive Format. Okay? And the good thing about this is you can take it across multiple platforms. Okay? So if you look into this, you can see there are again various file formats that you can do. So you can do it in something like XR format. So if I open this, you can see you are going to, in this case, it's actually defining what's your chassis. Okay? How a chassis, and you can see it also tell you what the left wheel is, what the right wheel is. So you can also put a hinge. If you want a hinge, you can put a hinge. If you want to have an arm, you can take in an arm, you can put it on it, and then you can say, you know, I have 3 degrees of freedom, 6 degrees of freedom. You can put it in the arm. You can say where it's placed on where is the center of gravity or center of, you know, thing for the arm. Where is it on the rover? Everything you can define, and you define the motions of it, and etc. Okay. So basically, you put in all the kinematics and everything. It comes here. So this actually gives you the model, the structure, right? Okay. So how do we actually go about doing it, right? So as you can see, usually, in order for this to be created, you generally have different files, right? So we also create something like a launch file, right? And in this case, we are actually using a launch file for arguments. So there is multiple visualization environments. The most common is Gazebo, but it's kind of very good, but it's also kind of, you know, has more overheads in it. The simplest one is Orvis. And then if you want a very simpler one, there's also even a simpler one. There's more complex ones, and so on and so forth. Okay? Okay. So when I want to run this, you basically would need to download this, and then you would actually compile it. Once you compile it, right? So how do you compile it? So as you can see, to start with, you're going to download this folder, source folder. You're going to take my bot description, and then what you're going to do is you're going to do a catkin. Oops, wrong directory. Catkin make. So once you do it, so remember this. So whenever you do it, you should not get errors. If any. So also another problem is what I do is. So you see my source directory, it's got so many packages already. So I've been trying out this and left and right, and whatever it is, which one is easy, difficult, different concepts, trying to put all this. And what happens is sometimes I drag and drop, I get errors. Because one is conflicting with another, it's conflicting with another. And that's the reason why I ended up creating 4 or 5 different workspaces. You understand? So if there was any other conflict, but I'd say it was important, I just move into my different workspace. Right? And I don't include it, I don't source them, I keep them separately. Those are working, I keep them separately. You understand what I'm saying? Even though I have multiple workspaces, you don't have to activate all those workspaces. Correct? How do you don't activate them? You go to your bash.rc file and disable those things. That way, you don't look at those files. You understand? So that's what is happening. So I have about, I don't know, I probably have about here close to 30, 40 packages here. And once you do this, so since you're freshly compiled, because I have so much of this, so now I started to do this, I do always source, and then I do catkin, and I do devel setup.bash, which is just the one. That is mine. Just one I compile, I hit it because I want to now capture whatever I created now. Because I'm not opened a new window. You understand? You guys understand? I've not opened a new window. Every time I open a new window, everything will get refreshed. But I've not changed anything in my original directory, which is bash.connect or melodic.setup.bash. I've not changed anything. The only thing I've changed is this directory, so I want to update that directory. You did? So I started doing this, and now I will do ROS launch, because now I don't have to even do a code. My code is running. Oh no, I shut it down. Okay. Cross launch. And then what is my package that I put? Is my bot. Right? Yeah, my bot. What was it? Description? Yeah. And then I have only one launch file. You understand? So one hit and it's going to pop up everything. So here you can see, yeah, see, that's my RViz, obviously. Let it go. Okay, so there you can see it's already started a publisher 1, publisher 2, publisher 3, publishing a lot of things, but I cannot find my row, correct? So it's because it's actually my frame is different. So if I pull this down, yeah, so I have to say chassis, and yeah, so that will get fixed. There's my rover, oh, this up here. Okay. What happened to mine? That's the grid. Come on. Check. There was a called mine. Was everything was good. Oh, sorry. So I didn't add the. So if you go here, and here you can see this is my thing. I have to add the model. And then say, okay, and that's my role, okay? So this one is exactly what you guys are using, has the 2 wheels, and then, so it's basically, the description there says that put in a plank and put 2 wheels, and then that's what it is. You understand? That's not what you're using, but yeah, I'm using. So that's what it is, but there's also another model, I'll try to find out, I actually saw it's a circular frame and the 2 wheels, so that's another thing. All you have to do is just get rid of this as the center and then put it on a circular frame. Okay? So, and then, so this is just like an empty model, and then what you define is, as you can see, I'll probably show you next class, is you can see that we have like the control. So the control is actually going to add the kinematics to it, so then you can actually move. And then this is going to visualize it moving. Okay? And the good thing is, like, then you can also add so you can add like a camera, to it, and then you can put in like, like say some kind of objects around it, and you can actually visualize how it's actually seeing those things. So everything becomes a simulation. So this actually tells you what your rover is, when it actually moves, this is how it's going to move, this is what it's going to see, and this is how it's going to avoid, this is how it's going to go, and so on. Okay? Okay. So the other thing is, as you can see, no, it's not mind control. Yeah. So you can see that it's another one. I'm going to cut this one. See? And I'm actually going to put in the other package, which is gazebo, and that's the thing. So this is the other two, but there's a couple of steps. You can just Google or you can just go to the website and you can actually install it. So that actually is gazebo, right? So gazebo, see that's the same thing model, but this is a model in gazebo. That's just a 3-dimensional model. So most of the stuff that you would see in UAVs and everything, they use this, and it's the same tool, except that it's like a third-party add-in. Okay, so the RWIS is one level, and then you have this one is the second level. So not most of the people use this because it has very good rendering. You can actually import it from different formats, etc. So a lot of people use this for really professional type, even professional type of it. You understand? So again, so this one you can see that yeah, you can actually do the orientation, and then you can put some objects in, so that you will see, and then how you can control it. So that will be purely simulation, right? You don't have any piece of hardware with you. That's everything is virtual. Yeah. So I was telling you, right? So there's like a lot of companies that they only do this type of work. They only do this type of work. They are software companies, and all they do is they do work for robotic manufacturing or that type of thing. So they're given the model. They will be given equation after equation after equation. What's the dimension, let's say, of their arm? Let's say they have let's say, for example, a pickup, something that picks up and assembles it. They will be given that model, right? So they will say this has so much degree of freedom. This is the dimension of this. So this entire thing is constructed. Right? And then they will say, if I issue a command, this is how it's supposed to move. That's given by the equation. So they translate equations into animation. That's it. All they do is translate equations to animation. Clear? So actually what happens is, in reality, then they interface it with the actual hardware, so they can see what is happening here with respect to what is actually happening there, and they can even test out if the modeling is correct or not. Clear? Okay. So, and then there is also another tool, which is not that common. I forgot, let me see if I can pick up the. I don't think I have it, but
mine's a lot larger than yours. I think this is like the whole thing I figured out. You use this. I use both. This one's what the robot sees, and the other one's what He said this one was better. He said this one.
So that's another tool which is called STPR. That's a built-in simulator. What I basically did, it didn't work. Let me see if I can find it. Okay, there you go. So this is another one, which is a built-in simulator. So you can see that you can actually, that's a predefined maze. You can put it in, you can specify the robot. You can actually, for now it's just a circle. So this is actually, they also specify, as you can see, that it actually has two different types of scanners, which already comes with it. One is the laser one, another one is the ultrasonic scanner. So that's the laser one, is the black and red. This is the one, it basically is simulating. So you can actually see here, you can actually even go inside and give it what the parameters you want it to. And then, what is the idea is, you can actually make it to move. Okay? You can actually, because this is in the launch phase, then you can actually give a command saying that Ross topic, do go at a velocity at this particular angle, and it'll actually start to go at that particular angle. And actually, when it actually hits this wall, because you're not saying it, don't go and stop before the wall, go and hit the wall. It'll stop before the wall. And then you can say turn. So it'll turn. And then you can say go forward at this angle. So basically you can actually, this is like a pre-built one. We'll already have the maze, already has this, all those different things. Okay? So this is called STDR. Right? Yeah. That's the built-in simulator too. So it's not a built-in simulator. This you can also use, and you can actually use it for actually, and you can see, you can put in like different types of sensors, whatever it is, right? So even here, it's very simple. You can actually change information, and there's a lot of other things that you can also set. It's a simulator by itself. So, maybe like for the parts of the case. All right, okay. So we're going to stop here, and the next class, we're going to see about, I'll talk about more about the specific messages. And so if you guys can actually complete those tasks of moving the motor with Ross, installing it Raspberry Pi, and then also getting the IMU data to come out, okay? And then we'll go from there, okay? So you guys get it?
Yeah.
also trying to figure out how you can attach, your Arduino board directly to your Linux system. I'll also try to figure out something. Okay, and I'll upload some of these codes up online. Yeah, if you don't hear from me, just shoot me an email and I'll do it. Okay, so you guys have any questions? Alright, okay, let's go home. Okay, can I have my components back, please? Not the USBs though, but what about I gave